Okay.
Whatever. I'll do it later.
Number 6, final answer, tangent inverse of x. Tangent inverse of x. C was 0. Number 10, final answer, y equals ln of x all to the 4th. You cannot bring the 4 down. It's all of ln, that is, to the 4th. C is 0. They're talking about the domains. The domain is 0 to infinity. That's why they're talking about that one. Number 22 is an exponential growth one, right? Directly proportional. So you end up with y equals c times e to the negative kt. They went ahead and just left the ln there because they're like, whatever, all we want is k anyway. So that's okay. I guess you didn't have to get it in that full y equals c e to the kt form if you didn't want to. Yeah, number 6 was way back here. Tangent inverse of x. And tangent inverse, what's its domain? It has horizontal asymptotes of pi over 2 and negative pi over 2, but tangent goes on forever. Domain's all domain. Tangent inverse, I should say. Thank you. Number next one?
24.
1250. 1250. I had some algebra to do on that one, huh? 1250. Got it? 34 A and B. A is 1209. Tons of solid waste. Kids will have tons of fun if that's on that. An underestimate. How come? Lucy helped us out. Helped me out this morning. She was like, hey, this looks a lot like an FRQ from 2011 that we looked at last year. But she pulled it up and it literally was. Yeah, the same exact thing with different numbers. I don't think they talked about waste though. Oh, was it waste? That's really funny. I did not remember the Twitter feed on that year. But, kiddos, how can you figure out if a tangent line approximation? Well, yeah, it's ultimately what you're doing, right? It's a tangent line approximation. How can you tell if a tangent line approximation is an over or under estimate? You must look at the concavity. True. If the second derivative is negative concave down, every tangent line will be an overestimate. If the second derivative is positive, every tangent line will be under. Pause. Why did they plug in 1/4? They said 3 months. It was measured in years. You gotta watch out for those units. Gotta watch out for those units.
Yeah, exactly.
So since the second derivative was positive, hence the linear will be an underestimate. Hey kiddos, that was not free reign for you just to start being rowdy. Shush. Letter C was solving the differential equation, which yes, will end up with an exponential growth model. The plus or minus from the absolute value is absorbed into the constant. They called it A, you could have called it C, they just called it something different like a C1, C2. And then you solve with your initial condition. No.
Did you have to do C to find A?
To find A?
Yeah. That's what I did.
A was a tangent line approximation. What's the answer?
He didn't know I did extra.
Well, I mean, you did it early. That sometimes happens on an FRQ too. There have been years where kids have solved the differential equation early. And if that did happen and you get to like a part C where it says solve the differential equation, could you say refer back to A or B? I suppose so. But you might want to, when you do your FRQs, look ahead and make sure that you're solving what you need to be solving. Because sometimes you might do what they're asking for later, which might redirect how you're solving an earlier problem. So it might be a good idea to read through the entire FRQ before you start it, yeah? Just an idea.
That's it.
Dun, 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 dun.
Number 10 to answer.
Okay.
Yeah, don't worry, it's in the video. Oh, it is? Oh, it is in the video.
Look for now. Okay. Any quick questions on evens or odds from homework? John?
Number 7.
Number 7? What was the answer to number 7? I just needed.
You can.
Check the odd in the back of the book.
I just asked a question.
Okay, any other questions besides 7? Lucy?
Oh, no, I just can do that.
Oh, you can do that. Oh, that's funny. All right, go ahead and do the front board, Lucy. You're the first hand I saw. Why don't you come to the sideboard?
Okay.
Kiddos, I did input your participation grades from this last grading period, so we're all starting over at 0. What? Because I inputted them.
God, Corey, you're in the same place as everyone else.
Oh, now I'm like.
Hey, Corey.
Jason, that was the one you were talking about, right? That one? Lucy, don't lose this that one. I don't like Corey winning.
Alright, kiddos.
Because there were like 2 that technically needed to be moved.
I want you to read the following because it intros this crazy type of function called logistic growth that the BC exam loves to test on. The AP exam does not require you to know it all. Those of you guys that took pre-cal with me, we did talk about logistic growth for about 1/5 of a section. And we had an example where there was a college flu virus that was on.
I remember this. I remember putting half a person
So we were trying to figure out when they would have to cancel classes.
It was like 2 days.
I don't think it was 2, I think it was like 10. But still, it starts with a T. I'm impressed. College flu virus. We were talking about how it's going to spread through the air conditioning vents. Okay. Kiddos, what do you see?
Logistic growth.
Good.
Steve, is this in 7.5?
This is the intro to 7.5. You don't actually have to write it down. I just want you to consider it. So, here we go, 7.5. Almost any algebra book will include a problem like this. Algebra meaning probably like algebra 2. A culture of bacteria in a petri dish is doubling every hour. Maybe it's more like pre-count. If there are 100 bacteria at time t equals 0, how many bacteria will there be in 12 hours?
C is the number of bacteria you start with. And
Yeah.
you're solving for y. And you should be able to find P of K since you're given that.
Oh, so we used the formula that we got yesterday, y equals C e to the kt. No, we don't use that?
I don't
C could be 1.
Not necessarily.
Wouldn't it be just 100 plus?
Tom, how would you answer it? Ethan, how would you answer it? Okay, then let's focus. So we're all trying to figure out about the algebra problem. What you guys are doing back there. We're trying to figure out, if they say 100 bacteria is what we start with, and every hour it's doubling, how many bacteria will there be in 12 hours? What would you do?
Just keep doubling. 200, 400, 800, 2
Couldn't we just do times 2 to the power of 12?
Yes.
Because you're doing times 2, times 2, times 2, every hour up to 12 hours, true?
Yeah.
Okay. Wouldn't this be maybe exponential growth? You have a base and then you have a power? Okay. Suppose a textbook editor seeking to add a little unit conversion to the problem to satisfy a reviewer changes 12 hours to 12 days.
Yep.
What would be the answer to the revised question?
In 12 days. I think you would say between 4, yeah,
Times 2 to the 12.
12 times 12.
12
4 days.
Times 24.
Because I have 24 hours in each day.
So 2 to the 24.
What?
Because
Does that
if
make
you were
sense?
to write that out with the units.
Because 12 days and every day is 24 hours, so 12 times 24. No big deal, right?
Yes.
Is the new answer reasonable? Plug it in your calculator. The culture of bacteria is doubling every hour. Somebody's like, well, that's too easy, 12 hours. Let's make it 12 days. You're like, okay, naturally then. 100 times 2 to the power of 12 times 24.
Whoa, that's a lot of bacteria. Okay.
Well, there might be
I feel like this 9 section is not even close to
times 10 to the 88.
Well, pause, read number 3. Does anybody read number 3?
Not even close.
Okay, is it your answer reasonable? It says estimated there are about 10 to the 79
Yes.
Powers on 10.
There's only 10 to the 79 atoms in the universe?
Oh, that's a lot.
Question!
Well, there's more atoms in a grain of sand than there are people in the universe. Or people in the world.
Not wrong.
No.
Wrong.
Wait, no, I'm confused.
There's more atoms in a grain of sand than there are number of people in the world. So more than 7 billion.
So if we multiply that by everything.
So there's more than 7 billion atoms in a grain of sand.
Yeah, but hold on, 7 billion only has how many place values?
I know, but you multiply that by what? How many grains of sand?
Oh, man.
What, trillions?
Okay, 10 to 79 looks too simple.
Okay, pause!
This world is
Is
too
this actually
complex.
Pause! Go research where you got that fact from. And go research if there are in fact about 10 to the 79 atoms in the entire universe. My point to this class is not debating what fact has been given us in this problem. So you go research. If you're like, I'm smarter than the book, cool. Come back tomorrow, tell me how many atoms approximately are in the universe. But my question to you is, what number do you have on your calculator? Times 10 to the power of what?
88.
10 to the power of what?
88.
Okay. So does it make sense that you're going to have as much bacteria in that petri dish that theoretically is more than the number of atoms in the universe?
No.
It doesn't make sense. Now, if you want to go research the number of atoms in the universe, according to what we have, that doesn't make sense. So this is impossible to, what's number 4 say? Sustain. This is impossible to sustain for 12 days, for bacteria to actually be doubling every 2 hours. It could be a pattern that exists for a while, but it's impossible to sustain. Suppose the maximal sustainable population of bacteria in this petri dish is 500,000. How many hours will it take for the bacteria to reach this population if the exponential model continues to hold? Now, without going too crazy, yes, we could solve that because we would just set our, what would our equation be?
Or 500K.
Well, I'm just setting 500 equal to, but it would be 100 times,
E to the 2.
we're just doing doubling. We're doing 2 to the power of, yeah, we could do t or we could do x, right? So we could divide 500,000 by 100. We could take ln of both sides and then divide by ln of 2. How long would it take for the population or the bacteria to reach that
Whole
number?
hour.
4 hours?
4.26 hours.
Okay. But question, does it make sense that bacteria would double every hour until it hits 500,000 and then just randomly stop?
No.
Does that make sense biologically?
No.
Bacteria doubles, 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 all of a sudden it's like, oh, beep, we're done, all right, everybody can stop. No. So this is not practical, but yet we do know that bacteria can double every hour. There's like doubling and half-lifing, and that happens biologically. So how on earth can this happen if it's not sustainable? How can we mathematically model it if it does have some sort of limit, and yet it doesn't make sense, it just goes up and hits that limit? What's a mathematical way of dealing with a limit such that it'll never hit it? Or that it won't go up and just hit? What if there's a horizontal asymptote at 500,000? How would the growth have to behave then if it doesn't just go up and hit and everybody, the timer goes off and says, okay, we're done?
Looks like our best shape.
Instead, it's going to keep on going, but then what's going to happen to your rates? So it is doubling every hour for a while, until, as it starts getting on the upper end where it's starting to approach that maximal sustainable population, it's going to start to taper off. Can anybody think of a situation where there might be a maximal sustainable population outside of the petri dish, and how that would naturally occur? Chickens. Sure. Chickens, I don't know if those are rabbits. The chickens naturally occur in nature.
People in like
How about gazelles in Africa? Gazelles in Africa, are they going to, if you have like a certain number of gazelles, are they theoretically going to populate, and is the population going to grow? But how on earth is it, well, couldn't it just grow? We have gazelles everywhere.
No,
All of Africa is flowing with gazelles.
chain, and then there's less of them.
Evolution. There are other factors, evolution, not there are factors that might limit the population growth, like
environment can't hold.
predators, like environment, like weather, like food, right? So naturally, a certain environment, supposed to be eating with peanut butter or not, so I'm in trouble. Not getting my protein. Anyway, coming back. Long story short, in nature, it makes sense that things won't just grow without some sort of limiting constant, right? Okay, so the function or the model that displays all of this is called logistic growth. And logistic growth says, yeah, it is growing exponentially, but nothing can do that forever. So then eventually it's going to taper off towards some limiting constant. And that limiting constant is going to be a horizontal asymptote. Guess what the horizontal asymptote is of the one I gave you?
500,000.
No, 50. Ooh. Why do I know that? Because it's in this spot. Because I know what a logistic function looks like. Slice minus lift. It's going to be the limiting constant over 1 plus c times e to the negative kt. Guess where the point of inflection is always going to occur? I can't tell you the time.
In the middle.
But I can tell you it's going to always happen in the middle of the population.
So that's why you got 25.
So that's where I got 25, and after that it was so easy, because all I had to do was take 25, set it equal to, and do a quick little solve. Because it's going to grow exponentially until it starts getting on the upper half of approaching that limiting constant, and then it has to slow down. It's not cheating. It's using my math skills. All right. Let's keep going. But before we can talk about logistic growth, we have to figure out how to actually find logistic growth from its rate equation, or I should say its differential equation. And we can't actually, I can't show you where logistic growth comes from until we review partial fractions. Whew, good, because we've done the partial fraction this year. We didn't do so hot on it because it's a pre-cal idea we didn't really have to do last year. So partial fractions are going to show up in BC. Let's talk about partial fractions first. And then as we have time, probably tomorrow, we'll delve into logistic growth. But just like exponential growth, I don't want to show you just the equation and have you memorize stuff if you don't know where it comes from. So we knew how to solve the differential equation if the rate is directly proportional to the population amount. We knew how to solve that one. Exponential growth came out of that one, so then we went ahead and worked through it. But logistic, we can't solve until we review partial fractions. So, how would you integrate the following? Parts, no. U sub, no. Back. Because if I tried U sub 2x minus 5, that's just, nobody's happy, right? Yeah. Complete the square. Oh, complete the square. No one thought of tangent inverse? What about complete the square? That would end up being 1 over x squared minus 5x. What's half of 5? 5 halves. What's 5 halves squared? 25 fourths. What we do on one side or inside, we have to do the opposite outside. Uh-oh. Why don't we do arctangent, even though sometimes we would? What's the problem? U squared minus a squared? That's not arctan. I need U squared plus a squared. And I can't make a negative because then that squared still should be a positive. It's not arctan. Good idea. Huh?
Is that not cotangent? Is this nothing?
Because that would have to be the entire thing negative, not just the minus. So instead,
What if you fact?
Why can't you do parts?
Yeah, you.
if you do parts,
Split it up.
Minus 3.
shh, but thank you. Parts, the question has been posed. I would have to keep this all together. If I put it in an integral, I have the same problem. I can't make it dv. If I make it u, the derivative of this, bring down the negative 1, make it negative 2 times u prime, it just got worse. So I don't want to make it u or du, but good idea. But why am I instead going here? The factoring's easy enough. If only I could say, oh, little fraction, where did you come from? If I could split it up, those could both be little ln's, right? But the dilemma is, stink, this guy would have had to have been multiplied by x minus 3 over x minus 3. This guy would have had to have been multiplied by x minus 2 over x minus 2. Well, stink, what number would have had to... We could do that mathematically. We could say, this left fraction, whatever constant he would be, A would have needed to get multiplied by x minus 3. True? to get a common denominator. B would have had to have been multiplied by what?
X minus 2.
X minus 2. And at the end of the day, what needed to occur when I put these two together? What was left? 1. That's ultimately what my partial fraction work is going to lead me to. And I'm going to have to think through it and say, well, hold on, a 1, there were no x terms left, right? So that means that whatever x terms I had over on this side, which would have been a plus bx, somehow that had to go away to be 0. And then whatever non-x terms I had, which were negative 3a and 2b, well, somehow that had to make 1. A plus b must have been 0. 1 had to come from negative 3a minus 2b. Ultimately, I have a little baby system of equations. So that's one way of doing it. The other way of doing it is I could just plug in x equals 3, because that cancels that out. 3 minus 2 is 1b. 1b equals 4, but maybe that's a little bit too much fun for right now. Long story short, mathematically, a plus b must be 0. And negative 3a minus 2b must be 1. I can solve that a is equal to negative b. So I can go ahead and plug in 3b. Oh, 3 times 0, sorry, 3 times 0 plus 1. b has to equal 1. 3b minus 2b is 1b. 1b equals 1, then b equals 1. If b equals 1, then a has to equal negative 1. And why does that make all the difference? Now I can see this as 2 little baby u subs with ln. And fairly quick work. Keeping everything straight as to which one's which. I can end up with took the one to be really cool. But are all partial fractions that easy? Maybe yes, maybe no. Are there shortcuts to some of these? Maybe yes, maybe no. But do you guys understand why we had to think of something else besides parts and besides arctan? Try plugging 1 over x squared minus 5x plus 6 into u, everything got worse. Try plugging it into dv, that's the whole problem, I can't integrate it. Try arctangent with completing the square, it didn't fit u squared plus a squared. Partial fractions is where I needed to go. Katrina.
Would you have been able to split it up as 1 over x minus 2 times 1 over x minus 3 and then like u and 2? No?
I wish. The problem is when we're talking about splitting them up with multiplying, we still have the problem of u times v. So we still have to think of the whole thing as our integrand, whereas if we can split it up with addition, we can deal with them totally separate. So that was an intro as to why we need it, because try arctan, try integration by parts, bad. What would you guys take with this one? We could try long division, but the bottom won't go in the top.
Split up bottom and top.
Split up?
Part method and then do,
Okay.
use it.
Yeah, we could do part method.
Oh, yeah.
Yeah, part method works.
Do you think yourself
Do we need partial fractions for this at all? What would you, I'm not gonna solve it, but what take would you take on this first part? Like what approach?
Use of
Yeah, just u sub with u equal to
x squared plus 4.
x squared plus 4. What approach would you take on the second one?
Just,
That bottom to the negative 1.
just make it negative 1, distribute, and then
No.
just, no?
No, you can't.
Oh, you guys don't see it?
Can we stop?
It's a rule.
Oh, it's arctangent.
Arctangent.
U squared plus a squared.
Oh. Yeah.
What? U squared plus a squared.
It'd be 5 arctangent.
That would be on the outside, right?
Okay, u squared plus a squared. Just be careful. I am showing you partial fractions is good, but you don't always need it when you have a denominator. Yes, we can split up. Yes, we can do u sub. Ooh, maybe you would have thought partial fractions, but arctangent worked on this one. We had a plus. Arctangent only won't work when we have a minus. Okay, it's just saying, once again, partial fractions isn't always necessary. But what if arctan doesn't work? What if u sub doesn't work? Ugh. Partial fraction decomposition. Pre-cal. Partial fraction decomposition. At the very, very beginning, Katrina, this one's for you.
Oh, now you divide.
Yeah. Before you ever think about arctan or u sub or partial fractions, whenever you see a rational function, a top and a bottom, always check the degree. If the top wins, we always need to do long division first. If the top wins, always do long division first. Don't even worry about any of these rules. So the first things first, if you do see a top with a degree higher than the bottom, do long division. Simplify your life. And I'm not going to solve for the entire thing, but we do know we would have our x squared. We could put plus 0x, we could put plus 0. We would divide by x plus 1, right? I guess as you guys are writing, I could at least solve it. That would be x minus 1, I think. Double checking. Oh yeah. With a remainder. Negative 2.
Okay.
I wanted to have 2 fast. Oh, negative 1. Coffee. Okay, so we could change this with a simple long division. We could change it to be x minus 1 plus 1 over x plus 1. Would that just turn the tables? Help you turn the tide? Take the integral, that's a simple ln. So long division, sometimes it makes all the difference. But the dilemma is, what if you can't do long division because the top doesn't win? And what if u sub isn't possible, and neither is arctan? Our answer must be partial fractions. Tomorrow, we're going to go ahead and work on partial fractions a little bit further, a little bit longer. And we're going to get into this thing called logistic growth. You guys have a great intro to logistic growth. You actually know quite a few key ideas to it. We just need to cover a lot more tomorrow. So tomorrow, no grading of homework, straight in, straight to notes. Let's play with partial fractions. And let's figure out where logistic growth comes from and how to work with it. Bye guys. Yeah,
Is there any way, do you want us to start the homework?
you can try. I wouldn't say that you necessarily should get super far. Bye guys.
I leave this one, I brought it inside. I think it's